welcome to Go Fun Facts Online. Look up at the night sky. What you see are pinpricks of light from stars and galaxies, islands of brilliance in an ocean of black. But what if the most colossal structures in the universe, the very bridges connecting these galactic islands, were completely invisible? What if the cosmos was filled with ghosts? Today, we're talking about one such ghost, a newly discovered, monumental bridge made of gas, stretching between two distant galaxies. It's a hidden river of cosmic material, and its discovery is rewriting our understanding of how galaxies live, interact, and die. In the vast, silent expanse of space, astronomers have unveiled a ghostly structure of truly epic proportions. They're calling it the Galactic Ghost Bridge, and it's a stunning confirmation of the powerful, violent forces that shape our universe. This isn't just a faint wisp of gas. It's a structure so immense it almost defies comprehension. Researchers at the International Center for Radio Astronomy Research, or ICRAR, have identified this massive stream of neutral hydrogen gas connecting two dwarf galaxies known as NGC 4532 and DDO 137. These galaxies are located in the Virgo cluster, a bustling metropolis of over 1,000 galaxies, about 53 million light-years away from us here on Earth. Now let's talk about scale, because the numbers here are genuinely staggering. This cosmic bridge of gas spans an incredible 185,000 light-years from one galaxy to the other. To put that into perspective, our own Milky Way galaxy, which we think of as enormous, is about 100,000 light-years in diameter. This invisible bridge connecting two relatively small dwarf galaxies is nearly twice the size of our entire galactic home. Imagine two towns connected by a bridge that is wider than the continent they sit on. That's the kind of scale we're dealing with. But the story doesn't end there. This bridge is just one part of an even more dramatic structure. Trailing behind these two interacting galaxies is a phenomenal tale of the same gas that extends for 1.6 million light-years. That's not a typo. 1.6 million light-years. This makes it the longest such feature ever recorded in the universe. Light itself, the fastest thing in existence, would take 1.6 million years to travel from one end of this gas tail to the other. If you tried to cross it in our fastest spacecraft, the Parker Solar Probe, it would take you over 3 billion years, longer than complex life has existed on Earth. This entire system, the two galaxies, the bridge between them, and the colossal tail trailing behind, provides a unique, real-world laboratory for studying how galaxies are built, how they interact, and how they are ultimately torn apart. So, how does a structure like this even form? A bridge of gas nearly 200,000 light-years long doesn't just appear out of nowhere. Its creation is a story of a cosmic tug-of-war, a billion-year-long battle between two powerful forces, tidal forces and something called ram pressure. Let's break those down. First, tidal forces. We're all familiar with tides on Earth, where the moon's gravity pulls on our oceans, creating high and low tides. The same principle applies in space, but on a galactic scale. The force of gravity isn't uniform. It gets weaker with distance. As the two dwarf galaxies, NGC 4532 and DDO 137, orbit each other, the side of one galaxy that's closer to the other feels a stronger gravitational pull than the side that's farther away. This difference in gravitational force creates a stretching effect, what astronomers call a differential gravity. This stretching literally pulls and strips gas away from the outer edges of the galaxies, flinging it out into the empty space between them. Computer models suggest that this process kicked off more than 1 billion years ago, when the two galaxies had a close passage, a near miss in their long orbital dance. This gravitational handshake was the first step in creating the bridge, pulling the raw materials out of the galaxies and into the intergalactic medium. But tidal forces alone can't explain the sheer amount of gas we see, especially that record-breaking 1.6 million light-year-long tail. That's where the second major force comes in: ram pressure. Ram pressure is essentially a cosmic wind. Imagine sticking your hand out of the window of a moving car. You feel the air pushing against your hand. That's a form of ram pressure. Now, imagine you're not in a car, but you are an entire galaxy, moving at hundreds of kilometers per second. And you're not moving through air, but through a superheated cloud of plasma that fills the space between galaxies in a cluster. The pair of galaxies, NGC 4532 and DDO 137, are currently falling into the center of the massive Virgo cluster. This cluster isn't empty. It's permeated by something called the intracluster medium, a thin but incredibly hot gas with temperatures reaching millions of degrees, about 200 times hotter than the surface of our Sun. As the galaxies plunge through this hot medium at incredible speeds, they experience an immense headwind. This cosmic wind is so powerful that it acts like a pressure washer, stripping away the loose outer gas from the galaxies and pushing it behind them. It's a process analogous to the way a meteor burns up in our atmosphere, but stretched out over 1 billion years. The combination of the galaxy's immense speed and the density of the hot gas cloud creates a powerful ram pressure, blowing the gas that was initially loosened by tidal forces into the vast bridge and the enormous, elongated tail. It's a 1-2 punch. Gravity pulls the gas out, and the cosmic wind blows it away. This brings us to a crucial question. If this structure is so massive, why are we only discovering it now? Why is it a ghost bridge? The answer lies in what it's made of. The bridge and its tail are composed of neutral hydrogen gas, the most abundant element in the universe and the fundamental building block for new stars. However, this cold, diffuse gas doesn't shine invisible light. It's completely invisible to optical telescopes like Hubble, which see the universe in the same way our eyes do. For centuries, when we looked at this patch of sky, we saw the two galaxies, but the colossal connection between them remained hidden in plain sight. So how did we finally see the invisible? The discovery was made possible by a revolutionary piece of technology, the Australian Square Kilometre Array Pathfinder, or ASKAP, a powerful radio telescope located in the remote outback of Western Australia. Unlike optical telescopes, radio telescopes detect radio waves. Neutral hydrogen atoms, when they're just floating in space, naturally emit a very specific radio signal at a wavelength of 21 centimeters. By tuning into this specific frequency, ASKAP can map the distribution of this cold, invisible gas across the cosmos. This discovery was part of a huge project called the Wallaby Survey, which is using ASKAP to create a 3D map of hydrogen gas in the local universe. Thanks to the survey's incredible sensitivity and high resolution, astronomers were finally able to detect the faint radio signal from the hydrogen gas connecting NGC 4532 and DDO 137. The data didn't just reveal the bridge and tail, it also showed that the gas disks within the two parent galaxies are still rotating, but in a messy, disturbed, and chaotic fashion, bearing the scars of their violent interaction. This discovery is far more than just a cosmic curiosity. It has profound implications for our understanding of how galaxies evolve. Galaxies are not static islands of stars. They are dynamic, living systems that are constantly shaped by their environment. Gas is the lifeblood of a galaxy. It's the raw fuel needed to form new stars. A galaxy that is actively forming stars is often blue and vibrant. A galaxy that has lost its gas can no longer create stars, and it slowly fades, turning red and dead. The Galactic Ghost Bridge is a vivid, real-time illustration of this gas loss process, known as galaxy quenching. We are witnessing, frozen in time, the process of these two galaxies losing their fuel for future generations of stars. Lead author Professor Lister Staveley-Smith called the finding a major step forward in understanding galactic interaction. The stripped gas, which is no longer gravitationally bound to its home galaxy, is drawn into the bridge, creating this vast umbilical cord between them. But here's where it gets even more interesting for scientists. Despite being a massive reservoir of the very stuff stars are made of, the gas in the bridge and tail hasn't formed many new stars yet. This provides a perfect laboratory. Why isn't it forming stars? Is the gas too thin and diffuse? Is it being pulled apart too quickly by the tidal forces? Is it too hot? By studying the conditions within this bridge, astrophysicists can learn about the precise triggers needed to kickstart star formation, or the factors that can suppress it. It's a cosmic experiment on a scale we could never hope to replicate. Perhaps the most mind-bending part of this story is that this spectacular, distant drama has a surprisingly familiar echo right in our own cosmic backyard. Our own Milky Way galaxy has two small satellite galaxies, the Large and Small Magellanic Clouds, which are visible from the southern hemisphere. For decades, astronomers have known that these two galaxies are also connected by a bridge of hydrogen gas and are followed by a long, trailing feature called the Magellanic Stream. And guess what? The Magellanic Stream was also formed by the exact same combination of forces: tidal interactions with the Milky Way and ram pressure from our galaxy's own hot gaseous halo. The system of NGC 4532 and DDO 137 appears to be a larger, faster, and more dramatic version of what's happening to our own galactic neighbors. By studying this distant ghost bridge, we can gain crucial insights into the past, present, and future of the Milky Way and the Magellanic Clouds. We are essentially looking at a more extreme version of our own local galactic weather. The Galactic Ghost Bridge is a powerful testament to the dynamic, and often invisible, nature of the cosmos. It reminds us that galaxies are not isolated entities, but are part of a grand cosmic web, constantly interacting, exchanging material, and evolving over billions of years. This spectacular, previously hidden structure, twice the size of our own galaxy, was there all along, a silent river of gas flowing in the dark. Thanks to new technology and human curiosity, we are finally able to see these ghosts and piece together the epic story of how our universe is built. Thank you for tuning in to G Fun Facts Online. If you enjoyed this journey into the unseen universe, be sure to subscribe for more deep dives into the cosmos.